Welcome to section 5.6. It's entitled Special Products, and it's basically an extension of 5.5 where we did multiplication, where we multiplied polynomials. But let me take a look at this one problem. This video should be a rather quick one. There's only 14 questions here, so let's take a look at this. Now, this is special in the sense that what does this mean when you raise this bundle to a power? Okay, and a lot of people think that this is, well, geez, if I listen to Professor Silvestri in other videos, he would say, well, that's got to be x squared, right? You square the x and you square the 10 to get 100, and that would be wrong, because I was very careful to say everything inside the parentheses gets squared. However, if there's a plus or minus sign, you can't do it. You cannot do it. So it just doesn't work. And look, I can give you an example with numbers. 3 plus 4 squared. Well, if that were the case, if you square the 3, you get 9. If you square the 16, you get that's 4, you get the 16, you get the number 25, which is not the answer. Because this is 3 plus 4 in parentheses is 7 squared. The answer is 49. So forget this concept. You can't. It doesn't work with when you have pluses and minuses. So let's go back to the original problem and just understand what this means. This is a bundle. I keep saying this. Things inside parentheses is taken. This is one bundle. It's one unit. You're squaring that unit. It looks like this. This is what it looks like. X plus 10 times x plus 10. Then you're doing the math correctly. And then you need to use a FOIL to do this. So first product, x times x. Outer, 10x. Inner, another 10x. Last is 100. And so the answer would be, well, the 10x and 10x would be 20x. So when I put this in the in here, x squared plus 20x plus 100 is the correct answer. All right, so make sure you understand this. I'll let you do this one. It's exactly the same as the other one. Only instead of 10, it's 9. I'll do this one. You know what this is? This is what this is. I'm going to do it in here. 2c plus 2. That bundle gets multiplied by itself. That's what 2c plus 2 squared is. So when I go ahead and do a FOIL, first terms, 4c squared. 4c squared. Okay, outer, 2c times 2 is plus 4c. Inner, plus another 4c. Last, 2 times 2 is 4. A lot of 4's here. Okay, so when I combine the like terms, I get 4c squared. Where's my squared? Squared plus 8c plus 4. And there's your answer right there. So let me erase all the stuff in between so I can at least see the green box. Check your answer. Great work. Okay. Square the binomial. Fancy word for what we just did already. Okay. This is a binomial. That bundle's a binomial. And you're going to square it. So you're going to do this. 9x minus 8. You're going to rewrite it so that longhand, so that you're going to do a FOIL. So if you're not FOILing, you're doing something wrong. So if I do 9x times 9x, the first terms, I get 81x squared. And then I'm going to have the outer term, 72. 9x times 8 is 72. That's a minus 72, excuse me. 72x. Oh, I made a mistake there. Okay, minus 72x. 9x times a minus 8. Then we have a minus 8 times 9x, which is another 72x. And then we got minus 8 times minus 8 plus 64. Remember, this is the first, outer, inner, last. And so the end answer is going to be 81x squared. It's going to be a minus 144x, minus 72 times minus 72 subtracted, plus 64. And that's going to be your answer. That's going to be your answer right there. Okay. Check my answer. Fantastic work. Nice work. I'll let you do this one. It's the same stuff. I'll do this one. Okay, because it's a little harder. And so what I'm going to do is, I might even do it over here. Let me clear this here. Don't save. File, new. Okay. Okay. This is what I got. You know what? That bundle, this is the bundle, okay, it's being squared, so I have to multiply it out like this. Let's make a cleaner looking B. Okay. We're going to do our FOIL. First terms. 25. B cubed times B cubed. B to the sixth. Outer. Plus 5 B cubed T squared. Okay. Inner looks like another 5 B cubed T squared. And then the last is T squared times T squared, which is T to the fourth. T to the fourth. I'm going to put that answer right into the computer and be happy that I get a green box. 25. B to the sixth power. 56. No, it's 56. I can't even read my own writing. 5 plus 5 is 10. These are the like terms. 10 of those B cubes. T squares. And then we're at last, T to the fourth power. Hit enter. Nice. Special. Now, this guy here is an interesting pattern. See, look at this pattern. Basically, you can get the answer and get this. But I want to show you what this is called. When you see a situation where you've got exactly the same terms, S's in front, 8's in the back, plus and minus, it's always going to happen that you're going to cancel the middle term. Okay? Basically, it ends up being what's called a difference of two squares as your end result. You square the S's, you square the 8's, and because it's plus 8 minus 8, when you do the last terms, you get minus. So it's always going to work out that way. It's going to be, even if you don't see the pattern, just do this. Just go ahead and do that. First terms, S squared. Outer terms, minus 8S. Inner terms, plus 8S. Already, you can see that these are going to cancel out. 8 times minus 8 is minus 64. Negative. Cancel, cancel. There you go. That's the answer. There's the answer. And now this is another difference of two squares. And you know what I'm going to do? I'm going to use that pattern where I know that the outer is going to be minus 30W. The inner is going to be positive 30W. They would cancel out. It only works out when you get exactly the same first terms, exactly the same last terms, one's plus, one's minus in between. I'm going to say 25W squared. Okay, it'll always be a minus 36. Okay, this pattern you're going to see a lot. And you want to see it because it takes no effort really, once you get to see the pattern, to generate the end answer. Okay, now. Let's see what this is. Now, you might think that this is different. Okay? You might think that this is different, but if you take a look, okay, this guy here, that you don't want to change the 4 minus 5b. Leave it at the way it is. But if I move, I can move these two around. Okay, it doesn't matter whether you say 3 plus 5 or 5 plus 3, it's the same value. I'm going to put the 4 in front, the 5b, 4 in front, and this is a positive 5b. I can move those terms around. So it sort of looks like what we've seen before, where we have exactly the same first terms, exactly the same last terms. One's minus or plus, plus minus, it doesn't matter. I'm going to get 16, 4 squared, minus 25b squared as your answer. Okay, let's see if that's right. Sure it is. And let's go backwards. Let's go back quickly. Even if you didn't see this, this little trick here. Do a first, outer, inner, last. You're going to get two terms that cancel out to give you that. Everything basically ends up being a foil in Algebra 1 and 2. Most of the problems. Let's see what the next one is. Okay. 2s, 2s. That's good. 5d, 5d. Better. One's plus, one's minus. Great. Follows the pattern. I'm going to square the 2s. 4s squared. Okay. Minus. I'm going to square the 5d. 25d squared. Oh, I didn't put the square in there. That doesn't count. That doesn't count. I got to put this. Come on. It's not going in there. There you go. Now it's going to go in there. 25d squared. So the rest of this looks like we just got bigger problems to do. Yeah, that's all this stuff is. Okay, we'll do them. We'll do the rest of them. Let me clear this paper. Don't save. File new. Okay. But the long and the short of it is this. S plus 7. S minus 7. I'm going to multiply. I know you're supposed to go left to right, but when you're multiplying things, it doesn't matter the order in which you do the multiplication. Whether I do 2 times 5, then multiply by 8, or 8 times 2, then multiply by 5, you're going to get the same answer. And the reason why I want to do this first is that follows the pattern that I'm striving for, where you have a plus and a minus, the same first terms, same last terms. So I'm going to square the s minus square the 7, get 49. And that's what that square box is. But let's not forget there's an s that needs to be multiplied through. And when I multiply through, it's just a simple matter of saying s cubed minus 49s when you multiply through the s. That's it. That's all that is. Now this guy here is a little bit harder. Let's see if I can push it. Let me put some real estate here. I got 2x squared. And you know what? I'm going to expand this. This bundle squared is x plus 5, x plus 5. That's what that square is. And then you know what I'm going to do? It's the same principle. I got 2 times x squared times x plus 5 times x plus 5. We have 4 things that are being multiplied. The order of the multiplication doesn't really matter. So I'm going to take the worst part, do that, and I'm going to do first, outer, inner, last. You're going to get x squared plus 5x for the outer. Inner is 5x. Last is 25. And so I'm going to combine my like terms to get x squared plus 10x plus 25. And that's what that square box represents. But let's not forget to bring down the original 2x squared. That's also part of the problem. Okay, and so let me multiply through. This is a simple multiply job. This is going to be 2, I'm going to put the answer in the box here. 2x squared times x squared is 2x to the 4th power. Plus 2 times 10 is 20. X squared times x is x cubed. And then I've got 2 times 25 is 50. X squared. Because this is multiplying this as well. So the x squared comes along. Let's put a square there. Hit enter. Nice. Nice, 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 nice. Okay, this looks scary, but it follows the same pattern. Look, the same front terms, the same front term. I don't care that it's x to the 5th. The same back terms. So what I'm going to do is I'm going to say x to the 5th, x to the 5th is x to the 10th. There is no middle term if you do the first, outer, inner, last, minus y to the 10th, when I square the y to the 5th. Okay, and then last, you know what? I'm going to leave you with this. This is very simple. Well, you know what? I'll just do it. Why not? Just do it. Don't save it. Let's start over again. Let's see. File, new, because it's a little bit more difficult than what I did. So I will do this, though. I'm going to say minus 4x squared. Copy that. I'm going to expand this bundle that's being squared. So I'm going to say 5x minus 2, 5x minus 2. I'm going to do a first, outer, inner, last. So I'm going to get 25x squared. That's the first. Outer is minus 10x. At this point, we've done this so much, I think you're going to see the pattern. It's going to be minus 10x plus another minus 10x. Minus 20x. That's outer and inner combined. And then minus 2 times minus 2 is 4. That's what that is. Okay? Bring down the minus 4x squared. And I'm going to put the answer in the box because this should be easy to see. Minus 4 times 25 is minus 100. You multiply the coefficients and you add the exponents. X to the 4th power. Minus 4 times minus 20 is plus 80. X to the cube. Minus 4 times 4 is minus 16. X squared. When I multiply through those parentheses by minus 4x squared. And that's it. Now there's only one more section, section 7.7, and you guessed it, it involves division, and we'll do that in section 5.7. We'll see you there.